Statistics is all about describing the world with numbers. And beyond making your calculations or interpreting what the statistics might be saying, you have to understand the context of the numbers. Just like if you were in a science class and the units matter, 10 inches and 10 feet, 10 meters, they're all 10, but they're not the same distances. You have to be aware of exactly what's going on as you're doing things. Furthermore, it's important to know how and why the data was collected the way it was. And honestly, you have to make a judgment about whether the data is legitimate, useful, and even though you can calculate an answer, does that answer really mean anything when you look at the real world? They say you can lie with statistics. It is not really the numbers that are lying. It's the context of how the numbers are used that the lie may lay in. So, a couple of vocabulary terms, and honestly, all of Chapter 1 is just doing vocabulary. So, we have context of the data. Numbers refer to real things. What are the connections to those real things? Source of the data, who gathered it and why? Is there bias? Is there, at the outset, a reason perhaps to mislead the observer? And it may not be that this is intentional. Sometimes it's very difficult for us to remove our own bias in situations. How was the data gathered? Does it really represent the entire population that's under study? Okay, parameter. It's a numerical measurement about a population. Statistic, a numerical measurement about a sample. And I've given you a couple of examples. How many students are in the class who are over 21? How many girls in this class played varsity sports? The key to determining the difference between the two is the statistic is always a subset of the population. However, that can still be a little tricky because any potential group could be a population. For example, your class could be a population because you're doing samples or subsets of the class. But the class could be a subset of the whole school, and therefore, in that case, the class would not be a population. The whole school could be a subset of the district, and therefore, even the whole school might not be the population. So, again, context is what really tells you the difference between these two things. All right, descriptive statistics, branch that organizes, summarizes, and displays the data, and then inferential, what you do with that data. How do you use it to make conclusions about the entire population? In general, we don't do studies of the entire population. We do a subset, we do a sample, basically because it's just too hard to count every single one member of a particular group if the group is very large. I mean, even when we do the U.S. Census, they only try to do that every 10 years, and then they take, an entire year or more to go through that process. It's very difficult to do an entire population. So you want to do a sample, and then hopefully that sample will be representative of your entire population. So, some highlights of Section 1. Let's look at a couple of the questions that we had. And generally, this is what I will do. I will give you some highlights of what's in the chapter, or that section of the chapter, and then I will give you some examples. In Chapter 1, it's all vocabulary, but in future chapters, there will be math problems to calculate. So, first off, name at least 5 different contexts of the number 65. In other words, 65 what? Well, we could be talking about 65 years old. which, retirement age. We could be talking about 65 miles per hour, speed limit, 65 inches, how tall something is, 65 degrees, which is temperature, or 65, which is a Jersey number. And one of the reasons that we have to worry about context is, for instance, the first 4 of those examples could all be things that we could average. We can talk about an average age, an average speed, an average height, even an average temperature. But 65 as a Jersey number, what would it mean to say the average Jersey number is 57.2? Not exactly the same thing, so that's where context matters. What is the difference in your grade between 79.1% and an average of 79.6%? Now, some of you, depending on what you're thinking about, you go, oh, well, hey, it's just 5%, or 0.5%, 79.6 subtract 79.1, 0.5%. However, if you were, say, nearer to the end of the course, you might be going, oh, wait a minute, I'm worried about my grade. That difference could be a letter grade. And so again, here is a situation in which context really matters. Yes, they are only 0.5% apart, but 79.1, you'd have a C. 79.6, you would have a B. And actually, I tend to round from 79.5 up. So, not very far apart, and yet a dramatic difference in the result. All right. Now, one of the things when you are collecting data is, of course, there are things that might get in the way of you having accurate data. So, for example, what might prevent you from determining the number of people who get the flu each year? Well, people don't always report getting sick. They don't always go to the hospital or even call in sick, especially if they are in a job in which they don't really have sick leave or they can't just take off. They might lose their job if they called in sick. And so, while it might sound like a fairly routine thing, something that might be in the way of you getting accurate data. Census is another good example. We do that every 10 years, but hey, not everyone actually has an address that they live at. Not everyone trusts some stranger coming to the door or calling on the phone and asking for information about your family. And so adjustments would need to be made once you have collected all the data that you can. Now, stores want to require the wearing of masks when customers are inside their stores. Will this work? You've probably heard of some situations in which people have thrown a fit. I was in the store a few weeks back, and I noticed the people behind me in the checkout line not only were not practicing social distancing, but they weren't wearing any masks. And I mentioned it to the clerk, and they were like, we are told not to enforce the rule, because they didn't want any conflict that might end up, say, on the news, for example. So, in truth, if the store posts that everyone's supposed to wear a mask, probably most people will comply. On the other hand, there will always be people who will object, and the store may have a policy of avoiding conflict. And so sometimes, despite what the rules are, you will find people that evade those rules. And that could have to go into the data that you collect. Now, here's one for you. Do most diets fail because people don't have enough willpower? You may have seen a show. I don't know if they're still doing it, but a while back it was called The Biggest Loser, who could lose the most weight over the process of the show. And of course, one of the things I think that show tended to do was reinforce the idea that it's all about willpower. So what do you think? Is it just a matter of willpower? I would say, well, maybe you need to justify how reasonable the diet is. How much effort is actually required for the amount of weight lost? If that is not the same for everyone, because in fact biology matters and can work against you, it's hard to say. It's just willpower. At one point, I found out that I had diabetes. They thought it was type 2. They said, hey, just lose some weight and it'll go away. And so I lost, 115 to 120 pounds. Went from over 300 pounds to under 200 pounds. And it didn't go away. And they said, oops, looks like you have type 1 instead. My bad. The point being is that biology has some say in what you can and can't do. I have a watch where I can look at how many active calories I spend, how many minutes of exercise I do, and sometimes I notice that the same amount of exercise that I'm doing physically, whether that's walking, running, riding a bike, or whatever, will not produce the same amount of minutes on my watch. And so my body adjusted, and I need to now do more than I had to do before. And so again, some of the questions that we may want to study and collect data for may not have simple answers. All right, almost done here with section 1. First off, is the following a parameter or statistic? 19.7% of Fresno County residents 25 and older have a bachelor's degree. It is a parameter. Okay, even though it says 19.7%, that is of all the Fresno County residents that are 25 and older. Okay, now you might have thought to yourself, well, wait a minute, the 25 and older is just a subset of all the ones that we're talking about in the county that could exist, but that's the particular group that we're looking at. And so the 19.7% is what we found to be true of this entire group that are 25 and older within the county. Now, let's suppose that we said 23.2% of Fresno County women residents 25 and older have a bachelor's degree. Notice I have an extra word there. I'm now taking a subset of all the people that are 25 and older. And in that case, it would now be a statistic because the women are a subset of all county residents. And so, that does it for section 1. Again, mostly just vocabulary. And, when you get to the homework for this section and really all this chapter, it will be similar. Vocabulary terms, multiple choice, pick which one fits the situation.